Good afternoon. Good afternoon to all of you. So now I am going to start the next session, and obviously it is the last session of 3 days your training program on MATLAB. So last 2 days and also in the first half you learned a lot of things regarding the MATLAB, no, the basic MATLABs and algebraic operation using MATLAB, how we can solve the differential equation using MATLAB function, and also you will learn the how we can draw the graphs taken from the functions and taken from the data set. Okay. Now I will discuss some special, basically a particular features of MATLAB. So, or we can say that this is a special topics of mathematics, the optimization and operation research. This is a very specialized topics in mathematics. This is not suitable for all the users or not required for all the users. So in MATLAB, there are a lot of different units or different models. No? One is like your optimization and operation research problem. Another is image processing unit or module. Another is graph module on graph theory. Another is module on fuzzy mathematics. A lot of things are there. So in this starting training program, we just introduce to you the basic operations and one particular cases of mathematics, the solution of differential equation, and how can we plot the graphs. Graph plotting is very essential in every mathematical investigation. And in MATLAB, there is a very simple commands you have to write to draw the graph, or any kind of data or any kind of function can be plot in the screen in very simple way. But in optimization and operation research problems, there need to some write the codes. So what is the optimization problem? Optimization is one thing and operation research is another thing. Okay. Optimization means it may be your non-constant optimization, single objective function with certain constraint. There is no constant, that means unconstant optimization problem. The constant may be multiple, the constant may be non-linear. uh, your objective function may be linear, objective function may be non-linear. So lot of combinations are there. So we try to understand how we can solve this kind of optimization problems. And another feature is that the operation research problem. Lot of techniques are there in operation research. So we'll try to introduce you how we can solve optimization problem and operation research problem. So one of the main topic of operation research or optimization things or basic topics of operation research is linear programming problem. So almost all students are learn the LPP, linear programming programming, in UG standard or PG standard. Okay, so there is no problem. So I am starting from the solution of LPP using your dual simplex method. Now everybody knows the LPP can be solved using simplex method, and dual simplex is a modified form of the simplex method. It has some advantage. There is no concept of begin. So that's why we can use the dual simplex method. But simplex method is the pioneer method to solve the LPP. Now I'm just considering the general form of the LPP. So normally we are solving the LPP in simplex method or two-phase method or any other kind of method. In that problems we are considering the maximization problem. But here we have considered minimization problem. Minimize ftx. Ftx means this is the objective function. Means c1 x1 plus c2 x2 up to cn xn. And every your LPP they have some constant. So constant may be of three types. One is less than equal to type, another is greater than equal to type, and another is the equality type. No? So here we consider the, okay, 1 minute. So this is a very standard form of LPP, linear programming problem. So in this problem, we consider minimization problem. That one is written in the form of ftx. Ft means f basically is a column vector. So we are transforming it to multiply with x. X is a column vector. F is a column vector normally. So we are considering it is a row vector. And I have already mentioned that there are three type of constant. One is less than equal to type, another is greater than equal to type, and another is the equality type constants. So this is the general form of the standard LPP. But in our MATLAB programs, all the less than equal to and greater than equal to constant can be converted to less than equal to constant or slack form constant. If any constant is greater than equal to type, then you should multiply that constant by -1 to convert the greater than equal to sign to less than equal to sign. That means all the inequality constant can be considered as a or can be written as a less than equal to type constant. But in this case, the right hand vector may be negative. So there is no problem in your MATLAB. Another classification of constants are equality constant. So see that we have considered two type of constant with respect to MATLAB programming. One is ax less than equal to b less than equal to constant, and another is aeq x equal to beq. That means we classifies all the constant as your less than equal to type constant and equality constant. Okay, and see that in general LPP the x should be greater than or equal to 0. But in MATLAB there is a extra facilities. You can define the lower bound and upper bound of the variable x. It may be negative, starting from negative, it may be positive. There is no problem in MATLAB. So this is another feature of MATLAB programming, that bounds of the variables can be negative to any finite number. But in conventional LPP, the bounds are 0, lower bound is 0 and upper bound is infinity. So this is the beauty of MATLAB. In MATLAB, the variables can be considered as the bounded. Okay. Now we consider a particular example. See that here problem is minimization, z equal to -x1 minus x2 by 3. That means the problem contains only two variables, and the system contains lot of your constant. Some constant are equality type, some constant are your less than equal to type. See that these are the less than equal to constant. These are the less than equal to constant. Okay. So see that in the last but one less than equal to constant is -1. That means negative. Right hand side is negative. In all other constant, the right hand side components are positive. And the last constant is the equality constant. That means the system has only one equality constant. And see that here the x1 is bounded between -1 and 1.5, and similarly x2 is bounded between -0.5 to 1.25. So this is the given input. Okay, there is no problem whatever be the bounds. MATLAB will automatically solve. So for this problem, we construct the matrix A. A is the matrix corresponding to the coefficient matrix corresponding to the less than equal to type. So see that the first two of the matrix are 1 and 1. Elements of the first row are 1 and 1. See that the first constant, the coefficient of the first constant are 1 and 1. And coefficient of the second constants are 1 and 1 by 4. That one is the second row of the matrix. And see that the coefficient in the third rows are 1 and -1. So third row of the matrix 1 and -1. And last, your inequality constant is minus x1 plus x2 and less than equal to 2. So coefficient of the last row of the matrix A are -1 and 1. Okay, so this is the matrix A. And what is the matrix vector B? Is the coefficient matrix, B is the right hand vector. So right hand vectors are 2, 1, 2, 1, -1 and 2. Just simply the right hand elements of the constant. So this is the vector. And there is only one your equality constant, and its coefficients are 1 and 1 by 4. So the matrix AEQ. Note that AEQ is another matrix, but for this problem, A is a vector. Or we can say that this is a matrix of order 1 by 2, because one row is there and two elements are there. So AEQ is 1 and 1, 4. And what is the BQ? BQ means the right hand vector for equality constant. So there is only one value, half. So note that here we have written only half, not half, not written within the bracket, not within the square bracket. So MATLAB is an intelligent system. This is the very important thing. MATLAB is your intelligent system. So it is not required half within the square bracket. No, it is gets a one by one size vector or one by one size matrix. But here it is not required. Or we can write half within the bracket, but not necessary to write that one. Automatically the software will identify. And see that the lower bound of the variables x1 and x2 are, see that in right hand side we have already mentioned the lower bound for x1 is -1 and lower bound for x2 is minus zero point 0.5. So that one written as a lower bound vector -1 and minus zero point 0.5. And upper bound of these variables x1 and x2 are 1.5 and 1.25. Okay, so ub equal to, this is a vector, ub equal to 1.5 and 1.25. And see that if the lower bound in standard LPP, the lower bounds are 0 and 0. So we can write, if for the standard problem, then we can write LP equal to 0 and 0. Okay. And in general, see that the upper bound of the variables in any LPP are not mentioned. That means these variables can take any value up to infinity. So in that case, we can write ub equal to infinity and infinity. INF means infinity. So this quantity may be used to represent the upper bound. Also, we can write simply ub equal to a empty bracket. Means ub equal to just bracket without any argument. If there is no argument, then that kind of vector considered as a default vector. Okay. So we can write for infinite and infinite the default vector, that means the vector without any argument, that can be done. We'll show in the next problem on next slide. And see that if equal to -1 and -1/3, this is the coefficient for the objective function. See that the objective function is -1 and minus x1 and minus x2 by 3. So the coefficient of the objective function are -1 and -1 by 3. That one is denoted by the variable f. Okay. So these are the input for an LPP. And you have already learned during this your training program, option is another parameters in any your MATLAB function. So here we can enter the options using the optim. See that the name of the function optin options. This is the name of the function available in MATLAB. But option is user defined variable. This is user defined variable options, but it is very suitable variables. Options indicates that some option can be given through this function. So optim options is the name of the functions, which includes linprog. Linprog is the function which is used to solve the linear programming problem. So that one is written within the course. And linprog is the first parameters for this kind of option. And see that to solve any linear programming problem, there are a lot of algorithms, dual simplex algorithm, simplex method, two-phase method, and interior point method. Lot of methods are there. So we can explicitly define here which type of algorithm we would want to use. So algorithm written is quotation, single quote, and its value is dual simplex. That one also written is quotation. And three dots are there. And display. That means we can want to know the optimum solution only. That is the value of the variables and the value of the objective function. Sometimes we would like to know what are the each and every steps of the your simplex table or dual simplex table. So if we want to know the every steps, then we can write within quotation ITER, iteration. This is the short form of iteration. So this is the value of the display. So there are three possible values. Here, one is your iter, another is your last, and another is your no. Like that. I am coming for the all possible parameters of this option function. Fung represents the tolerance. 1 minus 6 means 10 to the power minus 6. So we can allow the 10 to the power minus 6. That means the tolerance level is 10 to the power minus 6. We can increase or we can decrease the tolerance level. And we can also insert the maximum iteration number. So it is generally happens that if your problem can solve or needs your say 10 or 12 iterations, and you are written here 100 iterations, so there is no problem. If the problem needs 10 or 12 iterations, so after 10 or 12 execution, the problem or the method automatically terminates. If it needs more than 100 iteration to solve the problem, then the problem will terminate, then the procedure will terminate after 100 iteration. So this is the limit. So this is the limit of iteration. If you don't mention this value, then there is an automatic value will be assigned for max iteration parameter. Okay, and this is the main function. This is the main function. Lean prog. This is the main function to solve the linear programming problem. So you have to remember what is the function to solve linear programming problem. So name of the function is linprog, lean prog, and these are the arguments. What are the arguments? The first one is if. That one first argument should be the your vector for the objective function. So f represents the vector for objective function. Then A means the matrix corresponding to your inequality constant. B is the right hand vector for the inequality constant. AQ is the matrix for the equality constant. BQ is the matrix vector for the equality constant. LB is the lower bound of the variables. UB is the upper bound of the upper bounds of the variables, and option is this one, the already mentioned. So option is not compulsory. If you may omit the option parameter, then there is a default setup. There is a default setup. Perhaps the default setup for linear programming problem is the dual simplex method, because dual simplex method has some advantages. So, okay, so these are the parameters. Parameter may be less than this number of parameters. So what is the total number of parameters here? 3, 5, 7, 8. In this function, we have used total 8 parameters. But this number of parameters can be reduced for different type of problem. I am coming for that cases. Okay, so this is the calling function, linear lean prog is the calling function, and these are the lot of parameters. And in left hand side, already you have seen that in MATLAB, you can assign more than multiple variables with a function. This is not happening in C language or C++ language. All this language takes, C++ takes only one variable. That means that languages calculate only one variable at a time. But in MATLAB, it is very interesting thing that the MATLAB can calculate more than one values or calculate lot of things, but that lot of things, as per our requirement, we can extract from these functions, from that output set. That means x is one output and x value is another output. So x represents the solution vector and f represents the value of the objective function. Okay. So these are the two outputs for this linear programming problem. This is the sufficient. So after getting x and f value, that means the x vector, solution vector, and value of the objective function, we can display using the we can show the result using the display function or a printf function. That are the output function. So display solution is, then this x, this means the solution is, then the vector x will be print in the scale, and display value of the objective function is so a print. So you have already knows what is the use of this kind of parameter. Okay. So this is a very simple representation, for your uh, LPP to solve using MATLAB. Okay. Now see that some options are written with certain parameters in option variables. So algorithm, see that in the option algorithm, its possible values are your dual simplex, we have already mentioned. Interior point method is another, simplex is another method. So these three methods can be used to find the solution of an LPP. Then see that the display is another your parameter or option. So the possible value of display are of iter means is iteration, final means you will get the final solution. And tolerance function, see that says the function tolerance level default values 10 to the power minus 6. You may change to 10 to the power minus 6 to 10 to the power minus 5, or it changes to 10 to the power minus 8 like that. Max iteration, see that defines the maximum number of iteration allowed, but the default value is auto. If you remove this parameter maximum iteration, then the computer automatically or MATLAB software automatically uh, repeat the your iteration up to the last stage. That means up to the last stage means when the your your optimality condition will satisfy. What is the optimality condition? You know, for the simplest method, the optimality condition is zj minus z greater than or equal to 0. So the procedure will repeat up to the up to the last stage. Last stage means when we get the optimal solution. And if we mention the number of iteration, that iteration may or may not give the optimal solution. So there is a dangerous issue to assign the maximum iteration value. So it is better to avoid that maximum iteration parameter. Okay. So what are the possible use of linear programming? That means possibility of the argument. See that in the first function name is same linear programming, but the number of arguments are three, f, a, and b. This indicates that f is the objective function, a is the matrix for less than or equal to type constant, and b is the right hand vector for such constant. So when this kind of parameters are useful, if the problem has no your equality constant and the lower bound of the variables are zeros, all variables, sorry, lower bound of all variables are zeros and upper bound of all variables are infinity. There is no upper limit basically. So for this kind of problem, we can just use simple three variables to solve the linear programming problem. If the equation contains your some equality constant as well as non-equality constant, then we can introduce two parameters for the equality constant. One parameter is, or this is nothing but a matrix AEQ, and the BEQ is the right hand vector for the equality constants. If you want to introduce the lower bound and upper bound, or you may introduce only the lower bound, or you may introduce only the upper bound. Not necessarily you have to introduce upper bound and lower bound both together. You may use only upper bound, you may use only lower bound, or you may use both upper bound and lower bound simultaneously. If you need to introduce upper bound and lower bound, then you can write LP and UV vectors, another two vectors. And if you introduce some parameters, some option parameters, then you can write the option. So these are the four possible your parameter set or input set for the linear programming problem. Now I coming to the another kind of problem. That one is known as integer programming problem. So what is integer programming problem? So both the linear programming problem and integer programming problem are similar, but the extra condition is imposed on the nature of the your variables. In the linear programming problems, the variables are any real number. That means it may be integer, it may be your fraction. But in integer programming problem, at least one variable should be integer type. Okay. Or we can assign all the variables are integer, or we can assign one variables is integer type, two variables are integer, three variables are integer, or all variables are integer. As per requirement, we can assign which particular values takes the integer value and which other variables takes the non-integer value. That means a general arbitrary real number. So for this purpose, we have to define one vector. We have to additional vector. So that vector name is int con. So you may use another vector to represent which variables are integer and which variable are not integer. Okay. So another additional vector is required to mention the number of variables which are integer. So to illustrate this method, we consider this minimization problem. This is also minimization problem because MATLAB solves the minimization problem. So here minimize j equal to 3x1 plus 2.5 h2. Okay. So this is the problem. There are two constants. Actually, see that here the constant are less than or equal to type, but actually this constant are greater than or equal to type. No, because see that all the terms are multiplied by minus 1. So if you change to positive 1, then both the constant becomes greater than equal. Okay, there is no problem because as per requirement of the MATLAB codes, we need the constant should be less than or equal to 10. So here see that the variables x1 and x2 are integer variable. That one already mentioned, and lower bound is 0 and upper bound is infinity. That one is not explicitly mentioned, but we assume that the variables are your 0 to infinity. So here, what is the your objective function? F equal to, see that f equal to 3 and 2.5. Okay, so that one is written at the beginning. And what are the your variables? One and two. There are two variables x1 and x2. So we written here a new vector int con, and that vector indicates which number of variables or integers. So here we have assumed that the first variable, variable number one, and variable number two, both are integer variables. So that one is assigned through a vector. Okay, so int vector means the vector which replaces the variable number. And A is the coefficient matrix for the less than equal to type your less than equal to type constant. So first row is -1 and -2. Second row is -3, -2. Okay. And semicolon replaces the separation. That means semicolon actually indicates that is the end of a row. So -1, -2, one row. Semicolon is the termination of the row. And -3, -2 is another row. And B, see that the B is the right hand vector. So -20 is the first element and -50 is the second element. That one is the separated by semicolon. Semicolon means termination of a row or termination of a line in a matrix. You can see. And see that for this problem there is no equality constant. No? Both the constant are less than equal to type, so there is no equality constants. So for this reason we have write a eq equal to empty set. Within bracket there is no argument, empty bracket, and b eq is the empty bracket. Okay. And lower bound is 0 0. There is no bounds on bounds for x and x1 and x2 are mentioned. So we assume that the lower bounds are for both the variables are 0 and 0, and upper bound for both the variables are infinity and infinity. Okay. Now see that what is the function to solve the integer programming problem? The function for this problem is your function of this problem is your int. See that int length proc is there, but one prefix int is introduced with the length proc. So int length proc is the function to solve the linear programming problem. So see that what are the parameters f, and second parameter is the vector representing the your integer variables is the coefficient matrix for the less than equal to constant. B is the right hand vector for the less than equal to constant. AQ is the matrix for the equality constant. BQ is the right hand vector for the equality constant. LB is the lower bound and UB is the upper bound. So see that the LB had for this case LB is 0 and 0 and UB is infinity. So for this case, this is the standard case. If the case is standard, then we can omit these two variables. We can remove these two variables for this from this your case. Okay. So from this for this problem, we can remove these two variables. Or if you introduce these two variables, there is no problem because LP and UB are defined, and because these are the default parameters for lower bound or upper bound, so default parameter may be omitted. Okay. And see that the like previous one, the output are x and f. X means the solution vector and f is the your value of the objective function. And lastly, we have display. The solution is, that means that string will be displayed on the screen, and x means the x vector will display on the screen. It is already discussed in the previous lectures. No, how we can print the other output variables or any particular string like that. The second, third line basically, third line replaces the display of the value of the objective function is then if. Okay. So these are the very simple cases for print the values. And see there's another variation for this problem. So see that for this problem there is no AEQ, BEQ, LP and UP. No, there is no equality constant. So we can remove AQ, BQ, LB, UP. So if we remove this thing, but we can use this type of representation. See that this is the very interesting issue. No? All these things are written as a empty vector. These are the four empty vector. First vector represents AQ, second vector represents BQ, third one is LB, fourth one is your UB. Okay, you can write in this way. So this way means these vectors consider the default values. Or if you remove all these things from this function, the reduced function will be this one. This one is the reduced function. So integer in main program, if objective function, int com vector a and b. So this is the sufficient for this particular problem. And if the problem has equality constant, then we can use a cube, b cube, and so on. Okay. So similarly, we can print the value of the vector and the value of the objective function. Now here we demonstrate three cases for three type of problems. Basically, if you introduce or if you consider the variables x1 and x2 both are integer, then the solution is this one. The x1 is 14, x2 is 4, and the value of the objective function is 52. Okay. In this case, both the variables are integer. Now, if we define int cont equal to 2, see that if int cont equal to 2, we have considered here int cont equal to 2. That means this means only the x2 variable is the integer variable. And what about other variable? Other variable are any arbitrary variables, arbitrary real number. It may be fraction, it may be integer. Only x2 variable is the integer variable. So in this case, the solution is 14.667. That is, see that this is not the integer one, but the second value is 3. That means this is the integer one. Okay. And the value of the objective function in this case 51.5. You see that the objective function has changed. No, it is less than the previous one. And if we consider both the variables are general variable, both the variables are non-integer. So for this case, we have defined int con equal to null vector. There is no vector, that means all the variables are your ordinary variable, or we can say that no variables are integer variables. So in this case, we obtain the solution as this one: x1 equal to 15 and x2 equal to 2.5. Okay, and the value of the objective function is 51.25. So see that for the parameter or the restriction on the variable, whether the variable is integer or any arbitrary real number. So depending on the nature of the variables, integer or non-integer, the value of the objective function are changes. So in this case, the values are very small changes, but for another type of problem, the value of the objective function may be large. Okay, changes is large. So what is the which one is the better solution? Sometimes we want to know that which one is better solution. So nothing is the better solution. But here see that in the last case, there is no restriction on the variable. There is no restriction on the variable. So this case gives the best solution, the minimum value. Here the problem is minimization problem. So 51.25 is the best result compared to the previous two. No, 51.25 is the least result. So this is the best. If we introduce the restriction on the second variable, so solution is not good. It is increased. Actually, we are trying to find out the minimum solution, but in this case, the value is 51.5 more. And if we introduce both the restriction on the both variables, x2 and x2 are considered as the integer variable, then the value is 52. It is more than 51.5. So the integer variables means some another restriction is introduced, another constant are introduced. So if you introduce more constant, the value will be your reduced. The value will be not good basically. So it is general theory in the linear programming problem. If you introduce the more constant, the value of the objective function will be for the minimization problem, the value of the objective function will increase or remain same. And in case of maximization problem, if the number of constant is increases, then the value of the objective function remains same or it is reduced. So this is the general things. Now we consider another type of problem, very useful problem, quadratic programming problem. Quadratic programming problem, or it is denoted by QPP. Quadratic programming problem means only the objective function will be the quadratic expression. Okay, quadratic expression, but your restriction or the constant either less than equal to type or greater than equal to type or equal to type. Okay. So there is no different things for the quadratic program problem. Another thing is that your objective function is quadratic expression, but the constant are linear. Okay, this is the very important issue. Constants are linear. Objective function is the quadratic expression. So any quadratic expression can be written in this way. What is the way? Is nothing but half into xt h x. Okay, xt h x. So x is the your corresponding symmetric matrix for any quadratic expression, homogeneous quadratic expression. H is the corresponding matrix. ftx, this part, second part, is nothing but the linear part, including the constant one. Okay, including the constant one. The constant term is there. So ftx the linear part, and half xthx is the your homogeneous quadratic part. Okay, and ax less than or equal to b means all the constant are converted to less than or equal to type, and some constant may be your equality constant, and the variables may have your lower bound and upper bound. And another condition is that the H, the matrix H, is a positive definite for the problem and the finite minimum. Okay, this is a sufficient condition to get the minimum value, finite minimum value. So H should be the positive definite. Positive definite means all the eigenvalues of that matrix is all the eigenvalues of the matrix are positive. And there are another definitions are there. Just this is a very simple consideration. If all the eigenvalues of a matrix are positive, then we can say that the corresponding quadratic expression is positive definite. Now, what is the function to solve the quadratic programming problem? That name is the quad. See that here quad is written, quad prog. Quad prog is the corresponding function to solve the quadratic programming problem. So see that the arguments in this case 1, there are two arguments, H and A. So H means your symmetric matrix for the quadratic expression, A is the linear terms. And this is applicable only when there is no your constant. That means for the unconstant quadratic programming problem, this function is applicable. Function name is same quad prog, but arguments are only two arguments, H and A. That one coming from the objective function. Okay. So this is helpful or suitable for the unconstant quadratic programming problem. If you have your constant less than or equal to type constant, Ax less than or equal to b. So in this case, the arguments are H, F, and AB. A means the coefficient matrix for the less than or equal to constant, and B is the right hand vector, similar to other cases. And case 3, see that if you have your less than or equal to constant as well as your equality constant, then we have your A, B, A, Q, and B. So see that here number of arguments increases to 6. In the first case, non-constant optimization problem, the number of constant is only 2. First case, in case 1, number of constant is only 2. In case 2, if you have a less than or equal to constant, the number of arguments are 2, 4. And if the equation or if the problem has also equality constant, then the number of argument increases to 6. And if there is a restriction on the variables, upper bound and lower bounds are there, then we can introduce lower and upper bound vectors. And if there is no restriction on the upper bound and lower bound, then we can omit UB and LB vector in the argument set. Okay, so these are the 4 possibilities, and these possibilities are also true for the linear programming problem or your integer programming problem. Okay, same things are there, but I have discussed in this case. So here we consider one quadratic programming problem. See that minimize j equal to half x1 square plus x2 square minus x1 x2. So this portion, this red mark portion, is nothing but your homogeneous quadratic form. So this expression can be written as half your xt, h, and x. And blue portion minus 2x1 minus 6x2, this is nothing but the linear portion, and that one is represented by ftx. Okay, to get the h, we take in common half from the quadratic terms. Okay, so half into x1 square plus 2x2 square minus 2x1 x2. So see that from this expression, from this quadratic expression, how we can generate the matrix H. So see that the diagonal elements of the matrix H, diagonal element of the matrix H are 1 and 2. This is coming from the coefficient of the variable x1 square and x2 square. So x1 square is the element of the 1, 1 position of the matrix. x2 square, coefficient of the x2 square represents the element of the a2, 2 position, and so on. So diagonal elements are coming from the square term. And here see that minus 2 x1 x2, Minus 2 x1 x2 means we can assign the values minus 2 in two places, 1 2 position and 2 1 position, because two variables are there, like variable x1 and x2. So for the two variables we can assign minus 2 in two position, at 1 2 position and 2 1 position. So how we can assign minus 2 in two positions? So we can divide minus 2 into two parts, minus 1 and 1, minus 1. So minus 1 and minus 1 are distributed in the 1 2 and 2 1 position. So this is the general formula to represent a quadratic expression. It may contain the multiple sets of variables. So this type of problem we can we can use the matrix size. If the number of variables is more, then the size of the matrix is also more. And see that f is very simple. No, two variables are there, so the f is minus 2 and minus 6. Okay, and variables vector are x1 and x2. So and these are the your constants, set of constant. Only less than equal to constants are there, but there is no problem if there is your equality constant. No? So that can also be solved by the same technique. So this is the problem under consideration. And also we have written H vector, H matrix, A vector, and so on. So these are the corresponding your representation or MATLAB code. H I have already mentioned. If already your f is the value of the objective function. See that what are the objective function? What is the objective function? No, sorry. F is the linear coefficient of the linear expression. Coefficient of the linear expression. No? So I have already mentioned minus 2 and minus 6, because minus 2 minus 6 is a column vector, but here we have written in a row, in a single line. So the rows are separated by semicolon symbol. Okay, sorry. And what is A? The A is the coefficient matrix for the your equality, non-equality constant, non-equality constant or inequality constant. So for this three constant, the first row, see that first row is 1 and 1, because the coefficient are 1 and 1. The coefficient of the second constant are minus 1 and 2. So second row is minus 1 and 2. Third one is 2 and 1. So third constant is 2 and 1. So the third row is 1. And the B vector means right hand vector 2, 2 and 3. Okay. There is no equality constant. So for this reason, we have written A equal to null matrix or null vector, A equal to null vector. Okay. And what is the lower bound? See that we can write the lower bound. There is no restriction. We have mentioned that x1 is greater than equal to 0 and x2 is the greater than equal to 0. So these are the standard things. No, standard your restriction on the LPP or quantitative programming problem and so on. So both the lower bound are 0 and 0. So we can write LB equal to 0 vector 0 0. We can write, but there is another alternative. This is the alternative technique to represent the zeros. So zeros means this function, zeros function create a vector with 0 element. So what is the meaning of the arguments? 2 1 means it has two rows and one your column basically. Two rows, one column. See that x vector is a x1 and x2. So we need a column vector to initialize the variable x1 and x2. So basically this generates a vector basically of size 2 rows, okay, 2 element and 1 column. First one represents the number of rows and second one represents the number of columns. So using this formula we can generate a null matrix. If you want to generate a 5 by 5 null matrix, then we can write zeros 5 comma 5. Okay. And here see that UB equal to null vector. That means there is no restriction on the upper bound. So we have not mentioned any argument within the upper bounds of the variables. So this is the red mark equation represent, or red mark code represents the your representation for the quadratic programming problem. So quad frog is the corresponding function, H is the symmetric matrix, H is the linear part, A is the coefficient matrix for the less than equal to constant, B is the right hand vector for the less than equal to constant, AQ and BQ for the your equality constant. Already I have mentioned 2-3 times. LB and UB are the lower and upper bounds. Okay. So and after calculating this X and FL, we can take in the printout. Okay. This is the major steps to find out the value of the variable vector x and value of the objective function. I am considering another example. See that in this example, the objective function is minimization type. All this problem considered in this my lecture are of minimization type because MATLAB directly solves the minimization problem. But our conventional simplex method, dual simplex method, or your no dual simplex method consider minimization problem, but two-phase method and dual simplex method, no sorry, not dual simplex method. Dual simplex method solves the minimization problem. Simplex, decay method, two-phase method, your revised simplex method, all are solves the maximization problem. Okay. So here see that there is no your linear part, only the quadratic part is there. No, see that x1 square, x2 square, x3 square, and subject to the constants. You see that number of variables are 3, but both the constant are equality type. Both the constant are equality type. So what will be the H matrix? H matrix will be the first element is half into, see that the quadratic form is written half into xt h x. So half we have to taken common half. If you take common half, then the coefficient of each square term will be 2, 2 and 2. No. So for this region, H matrix equal to 2, 0, 0, 0, 2, 0, 0, 0, diagonal matrix with element 2, 2, 2. And there is no linear term, so the f function f sorry not function f vector is 0 0 0. There is no linear term. A and B, see that A and B are the your coefficient matrix and right hand vector for the less than equal to constant, but for this program there is no less than equal to constant. So A and B are null matrix or vector. AQ and BQ, because two constant, both the constants are equality constants. So see that AQ matrix, the first row is 1 1 3 because the coefficient of the first row, first constants are 1 1 3. Coefficient of the second row or second constant 5 2 1. So the second row of the matrix AQ 5 to 1. It is obvious, no trivial things. And right hand vectors are right hand vectors contain 2 and 5. Right hand vectors are 2 and elements are 2 and 5. So BQ actually basically the right hand vectors, its elements are 2 and 5. And see that the upper bound and lower bound, all lower bounds are zeros. There is no your upper bound. So L be equal to 0 0 0 and U be equal to infinity infinity infinity. So these are the inputs, and this function quad prob H A A B A Q B Q L B U B will calculate the values of the variables vector x and the object value of the objective function. So this is similar to the previous one. What is the output for this problem? I have not mentioned the output of the previous one, but I have mentioned output for the this problem, this simple problem. So output is x equal to 0.8043. This is the value of the x1. The first is the value of the x1, first quantity, the value of the x1. Second one is the value of the x2. Third one is the value of the x3. And this is the 0.8478 is the value of the objective function. Okay. So this is a very interesting thing by considering see that what is the advantage of this code. So this problem can be solved by by coding in C programming or your C++ programming. So now when I'm studying my MSc program, then I've tried to written a code using your C language. So I have completely designed the program for solving the linear programming problem. All possible cases we have introduced, and the total number of lines for that program was 300. Okay, so there is a big program, but I have completed during my PhD, MSc studies. So see that if you ask me to write your C code or C++ code to solve this linear programming problem, it is very difficult for us because it takes lot of time, lot of methodologies to be incorporated. I see that what is the advantage of MATLAB, just using this quad probe function. This is the built-in function in MATLAB. By calling that particular MATLAB function, we can solve the linear programming problem, integer programming problem, and quantitative programming problem, and so on. Okay, so this is the beauty or advantage of use of MATLAB. We can solve same problem using C, C++, etc. But see that the MATLAB also use your Fortran code, C programming code, C codes to develop this particular software. Without that basic languages, we cannot develop any kind of your software. So another type of problem is coming in our operation issues. That one is called the uh, nonlinear optimization problem. Nonlinear optimization problem. Nonlinear optimization problem is more difficult to your linear programming problem or quadratic programming problem. Quadratic programming problem is only the objective function is nonlinear, particularly quadratic expression. But in nonlinear optimization problem, the objective functions your nonlinear. That means it may be quadratic, it may be cubic, or any arbitrary shape. And also the objective function, sorry, not objective, the your constant are also linear or non-linear. Okay, this is the special cases. In general, we assume that in the nonlinear optimization problem, the constants are also your nonlinear, not linear. Okay, objective function is nonlinear as well as the constant are your nonlinear. So here gx less than equal to 0. That means here also we classify two type of your constant. One is less than equal to type and another is equal to type. Okay. This classification is also your valid for linear programming, integer programming, or quadratic programming. So all these cases, the constant are considered as linear less than equal to type and equal to type. But see that the right hand vector must be 0. That means if there are something in right hand side, so all the elements or of the terms of the right hand side should be shifted to the left hand side to make the right hand side 0. Okay. So gx, hx and fx all are non-linear. And here also we can assign the lower bound and upper bound for the variables. Okay. So now we are considering one nonlinear programming problem. See that the objective function fx equal to x1 minus x2 power 4 plus x1 minus 2x2 power 4 by power 2. So obviously it is not quadratic, no. The first term, the power of the first term is 4, power of the second term is 2. So this is a nonlinear your function, objective function. See that the first constant is x1 square plus x2 square less than equal to 5. That means this is a nonlinear uh, inequality constant. Second one x1 minus 2x2. This is the linear constant but less than equal to type. See that the linear constant is a particular case of the nonlinear constant. Okay, so linear constant can be considered as a generalized form of linear nonlinear. And see that the third constant is the linear equality constant, linear but equality. So here constant may or may not be linear. That one was the main problem. The constant may be linear, maybe non-linear. We assume that all the constant are non-linear. Okay. But we are classifying the constant as less than equal to type and equal to type. So there are two types of constant involved in this particular problem. So what is the new thing for this nonlinear object optimization problem? See that we have defined here the function fun. It's maybe you can write f also, there is no problem. Fun or f, this is the user defined variable. Okay, there is no problem. But what is the new things here? See that at x it is written. At x means it declares that the x is a vector of appropriate size. Okay, it is an appropriate size. So see that the objective function is this. See that x1 minus 2 to the power 4 we have written, x1 minus 2x2 to the power 2 we have written. Okay, so this is the objective function defined here. Another thing is that there are nonlinear constants are there. Okay, so because the constant are there, so we have defined a function that name is non-line constant. This is the user defined constant. Okay, non-line constant means user defined. This is the user defined constant. This one. You may change this to another name. You can give the another name, not necessarily non-line constant. This big one. So you can change this name. This is user defined, but function. This function actually declare the function which have two types of vectors. C and CQ are the vectors. But the vectors are not necessarily the vector of numbers. Here the vectors are the expression. See that this is the first constant x1 square plus x2 square minus 5. So see that what is the minus 5? Minus 5 is coming uh, in the left hand side, because right hand side in the first content right hand side 5 is there. But our general formula, in general formula, the right hand side of all constants should be 0. So for this reason, we have shifted the 5 to the left hand side as a minus 5, and right hand side becomes 0. Similarly, for the minus 1 will be the in the left hand side of the second constant, and right hand side will be 0. And for the third one, 1 should be shifted to left hand side, and right side should be make at 0. Okay. So see that C is the nonlinear constant, less than equal to type, less than equal to constant. So these two constant are written within the vector C. Okay, and that one that are separated by semicolon. Okay, and equality constant, that one is denoted by CEQ, denoted by x1 plus x2 minus 1. That one is the third constant, equality third constant. If there are more than one equality constant, then we also use in a square bracket the first constant, semicolon, second constant, and the closing third bracket. Okay, so this is the technique to represent all the less than equal to constant and equality constant. Okay, so the set of constant are defined here. If there are 10 constant, then we can use 10 lines or 10 components here with C or CEQ. No, all the constant can be introduced using this technique. So we have defined the objective function, nonlinear objective function. We have defined the set of constant. Okay. So there are alternative technique to define the nonlinear equality constant, inequality constant. So there are another function, non-L con. We have defined, or we have use this variable. This is a variable name, non-L con. It indicates non-linear constant. So see that another function is there, deal. Deal is the your MATLAB built-in function. Using that deal function, we can define the constant, nonlinear constant we can define. So this is another alternative way. So I think it is the better way to incorporate all the equality constant or your less than equal to constant as a single portion, okay, a single part. And lower bound is 0, 0. There is no restriction on upper bound as usual technique. And here you can define the options of team options ape mean con. So here name of the function to solve the nonlinear constant is ape mean con. So other functions are also available, but here we have considered ape mean con. This function solves the nonlinear optimization problem. Okay. Algorithm, which algorithm is used? Interior point. Interior point is a method to solve nonlinear optimization problem. If you studied the operation research or optimization technique, then we have heard this method. Okay. Space iteration, maximum iteration 100, tolerance function is 10 to the power minus 6. All these things are similar. Okay. And another new thing is that apart from the previous methods, for your nonlinear optimization problem, basically interior point method needs some initial values of the variable. Okay. But the previous method, all the previous method, they don't need the initial vector, the initial case of the values of the variables. But this method, nonlinear, for the nonlinear programming problem, we need the initial value of the variables. So 0.5 are the initial value of the variable x1 and x2. So what is the how we can call the function? So left hand side x and fn. The function is ape mean con. Then fun is the objective function. X is your initial vector, and these are the your your empty vector. Mean there is no equality linear equality function. No, there is no right hand vector for linear your linear constant is the type. There is no equality linear constant. There is no equality right hand vector. So all these vectors are empty. LB, UB are defined, and all the nonlinear constant are defined here. So see that function, nonlinear constant function, is called with the symbol at. Yes, this is the your symbol to calling a function. These are the matrix. Okay, these are the matrix or vector. But nonlinear constant is a special type of function. To call that particular function, we have to use this particular add symbol. Okay, and option are the similar things. So this is the same text to call the ape mean con function. Additional thing is only this one, nonlinear constant. Other things are similar. So these are the your statement to display the values. So what is the solution for this problem? X1, X2 are this one 0.7321, X2 equal to 0.2679, and that of the objective function is 0.95. So this is the solution. Okay, so to solve the nonlinear constant, we have to remember the name of the function and its argument or the syntax of the arguments. Okay, which type of arguments are required, what is the meaning of each argument, this to be remembered, or, or all the input type, order of the inputs, and the name of the function. So these are the learning things of MATLAB code basically. So these are the possibilities. Okay, so we have discussed only the optimization problems. Okay, and we can see that these are the advanced optimization problem or the basic optimization problem. So how we can solve the optimization problem using MATLAB, just I have discussed in this up to this lecture. Okay, so LPP basically see that the LPP is the optimization problem. It's fine, but it is not the advanced thing. But optimization of nonlinear programming problem is the advanced things. Okay. Now I am coming to the problems on operation ratios. This is another specialized thing. LPP, integer programming problem. I think almost all mathematicians are familiar with this type of problems, but I am considering the another method. These are basically called the operations research method. So first one is the queuing theory. Queue means the line in a queue in a restaurant shop, queue in any kind of ticket counter, and so on. So in a queuing theory is basically see that the probabilistic model. Queuing is the probabilistic theory. It has some people will come in the queue after getting some service from the service point. The people are left the system. So that means there is some arrival rate or arrival mechanism, and there is some service rate or service system. So these are the basic parameter of any queuing theory. Lambda is the arrival rate and mu is the service rate. The lambda and mu are the standard notation to represent the arrival rate and service rate. No, for any queue, for any ticket counter, any restaurant shop, or any kind of queue, there should be two basic parameters: arrival rate and service rate. And sometimes we have to determine what is the probability of no customer in the system. No customer in the system. If the system does not have any customer, then there is no waiting time for the your users. So see that in the queue theory there are a lot of models are there. So based on the arrival parameter, m is the arrival parameter, second m is the service parameter, one is represents the number of channels. That means in railway stations, see that the multiple ticket counters are there. No, so for that case, if there are four ticket counter in a railway station, then MM4, this third parameter represents the number of channel. If there are four counters, then we have to write MM4. Okay, and infinity FCFS infinite, there have another meaning. I am not going to that one. So one means number of channel is one. This one may be 2, 3, 4, and many more. Okay, and in the second box or second parenthesis, there are three parameters. The first parameter is your important. First parameter represents the length of the queue. The length of the queue may be finite or length of the queue may be infinite. So in this case, we assume that the length of the queue is infinite. Okay. And in the second model, we will consider the length of the queue is finite. And FCFS means first come, first serve. So for this particular your queue model, if the arrival rate is lambda, service rate is mu, then we can determine what is the probability of no customer in the queue. So after calculation or after mathematical calculation, it is shown that the probability of no customer, that one denoted by P is equal to mu minus lambda by mu. That means depends on the arrival rate and service rate, we can calculate the probability of no customer. LS, see that LS is the another parameter, expected number of customer in the system. Expected number of customer standing in the system, that one is obtained by the mathematical investigation mu by lambda by mu minus lambda. So LS is the expected number of customer. LQ is the expected number of customer in the queue. Queue means on the number of customers standing in the queue, and system means the number of customers standing in the queue as well as the customer taking the service from the service point. Okay, so LQ means only the number of customers standing in the queue, and LS means the number of customers standing in the queue as well as they are getting the service from the service point. Okay, so LS is the expected. So these are the mathematical expression to find out the LS and LQ. So this is the expression is obtained from the mathematical rigorous mathematical calculation. And WQ is the mean or expected waiting time in the queue. The mean waiting time is this expression. WS is the expected waiting time in the system, including the service. So these are the parameter we obtain after rigorous calculation of mathematical investigation of queuing theory for the first model. This model MM1 infinity FCFS infinity model. So those are familiar with this queuing theory. They knows how we can get this expression. Okay. Otherwise, it is very difficult to find out what is lambda, what is mu, what is waiting time, what is queued, and etc. But if you want to learn the operation research, or we can, if you want to teach your student the operation research problems, so then you can consider queuing theory, or another theories are there. We are coming to that portion also. So these are the problem of operation research. So here we consider one interesting problem. Multiply your yard. So that means arrival rate is 30 trains per day. Assume that the entire arrival time follows an exponential distribution, and the service time distribution is also exponential with an average of 36 minutes. So this is the service time for a train. So one train is coming with lot of goods. To clear that particular train needs 36 minutes. So this is the average time to download the codes from the train to the another places or another car like that or another truck, etc. So this is the downloading time from a train to the another system. Okay, so average time is 36 minutes to clear that time, and per day 30 trains coming in a particular year. So question is uh, the average number of trains in the system, the average number of trains in the queue. What is that? Basically, find the following. Write the MATLAB code to find the following: the average number of trains in the system. How many trains will be stand in the system? Average number of trains waiting in the queue. Mean waiting time in the queue or the trains. Expected waiting time in the system. Okay. So these are the parameter we have to calculate. All these formulas are already mentioned in the previous slide. So lambda equal to lambda is the arrival rate. So input is a function to get the or to read the value of the lambda variables enter arrival rate. That one is 30 turns per day. We have mentioned already. So for this problem, lambda value of the lambda is 30, and mu is the service rate. So this is the input. You have already learned this to this function, input function. Okay. So after getting the lambda and mu, using the formula already mentioned in the previous slide, E0 equal to mu minus lambda by mu, and we displace the probability of the number of trains. So all functions are all the expression already mentioned here. Already mentioned here. So see that the expression for LS, LQ, WS, WS all are very simple expression. So we can easily write the code for MATLAB code to find the values of LS, your LQ, WS, WK, and so on. So this is a very trivial problem. No? This is the input output. And the model is MM1 in FCF is infinity. So here the number of your number of sorry, not number, the length of the queue is finite, and that one is n. That means at a time n number of customer can stand in the queue. So for this case the expression is more complicated. Pn represents the probability of n customer standing in the system. So this is a complicated formula. LS is complicated, LQ is complicated. So for this case, MATLAB code is required. But for the previous case, MATLAB code is not required because the formula is very simple. So using this MATLAB code, this is the very mathematical expression. So there are some rules to write the mathematical expression in a MATLAB code. So here I am not going details. So see that the expression are written here. PN, okay, PN means probability of n customer in the system, and then we have calculated row and LQ, WS, WP, etc. So just it is the direct transformation of the mathematical expression to the MATLAB code. Now I'm coming another kind of problem. Problems on inventory control. Inventory control, inventory control means the management of some goods to store in the your storage capacity or storage building. So suppose you are doing some business, if you collected some goods from the market and you store in your storage space, and gradually you sell all the sell the goods per day or per month. You are taking the calculate, you are kind of considering your time spent is a week or a day or a month, like that. So lot of parameter associated with the inventory control system. So inventory control system is a very big, very interesting research problem. Research area. Inventory control is a very big, very interesting research area. So we can see that at this moment in our country, in India, more than 500 researchers are working in this area. And throughout the world, you can find out 3,000 or 4,000 researchers are working in this particular problem, inventory control or inventory management system. So inventory, to solve an inventory management problem, because it has lot of your parameters, lot of concept, lot of possibilities. So lot of problems can be considered, and also see that the demand of a market of a particular commodity is not the fixed one. This is probabilistic. Sometimes it is fuzzy quantity. So fuzzy inventory control problem also a very research area, because I am talking about this because lot of participants either are research scholar or the faculty, so they knows about the importance of research things. So I can suggest you can do your research work in inventory control system in Krebs world, probabilistic world, or your fuzzy world, okay, fuzzy set. So here we have considered very simple problem. Say that a contractor needs to supply 10,000 bearings daily to an automobile manufacturer. Upon initiating a production run, he can produce 25,000 bearings per day. Okay. The holding cost for each bearing in stock for a year is rupees 2, and the setup cost for each production run is 18,000. So these are the some parameter. Those who are familiar with inventory control, they knows how the meaning of this type of problems. Otherwise, it is very hard to identify what is the meaning of this type of parameters. Because I am teaching the operation research for last 15 years, so I have little bit idea about this parameter and inventory control system, etc. So I have. So what is the problem? The problem is to find the following: find the optimal lot size, which will minimize the total production cost or total system cost, determine the optimal cost, cycle time, and so on. Okay, so here these three terms we have to determine. So for this problem, see that the demand is 10,000 per day. Demand is the very important thing. Is the in any kind of your business. So what is the demand per year? So demand per year 10,000 per day. So 10,000 is multiplied by 300, not 365. Generally, the mathematician is doing that. If the demand is 10,000 per day, then we multiply this demand by 365. But see that any particular type of shop or any kind of government shop or even private shop, they have at least one day as a holiday. No, so there is 52 weeks as a holiday, and something other kind of holidays are there. Some festivals are there. So it is assumed that in a year 65 are holidays. That means that your industry or your shop is closed, and 300 days are working days. So for this reason, we have multiplied 10,000 by 300. Okay. And similarly, other cost we have mentioned C1, C2, or the holding cost. etc. cost. So these are the formula. Q represents the lot size, is the your optimal time circle, production cycle, and ATC represents the average total cost. So this is the expression, and T1 is the your time horizon, etc. So Q by Q. So these are the expression. These expression are obtained by solving some mathematical equation. It may be algebraic equation, it may be differential equation. In this case, some algebraic equation we have solved to find out this expression. Okay, but in so these expressions are very simple, so there is no difficulties to write MATLAB code. Okay, but in inventory controls, lot of researchers are working in this area, and they produce lot of your nonlinear equation as well as linear equation. In the inventory, the big problem will be consider lot of parameters, lot of restriction. And for any inventory control problem, lot of differential equation, it may be linear differential equation, it may be non-linear differential equation, lot of differential equation and algebraic equations are coming. And huge number of parameters, say more than 50 parameters are there in a inventory problem. So the question is how we can find out the explicit expression for each of the variables. So I mentioned here that Q is a very important parameter. This is called the stock amount. Q is the stock amount or called the lot size. So for this is a very simple case very simple problem. We have determined the explicit expression for Q, determine the explicit expression for T, and for ATC, average total cost, etc. But for the large problem, it is very difficult, or we can say it is impossible to find out the explicit expression for this parameter. So for this case, we need the help of computer. So we can solve this particular type of problem using MATLAB code. But there is another better method is there. Better software is there to find such kind of your nonlinear or highly or complex problem using another software. The software name is Lingo, Lingo. So Lingo software may be used to solve very complicated nonlinear and large equation. MATLAB is very difficult to handle such kind of problems. Okay. So your Lingo software is easily available free of charges in the your net. So you can download that particular your software and just you write the equation, the Lingo will give your solution. No need to find out the explicit expression for any variables. Okay. So that one is another your idea or concept to solve optimization problem. Now another topic is your reliability. No, reliability of any system, reliability of any components, reliability of a mobile of a particular company, reliability of a fan or air cooler, that one is produced by any particular company. So we are every time calculating what is the reliability of a system. No? So reliability is basically probability under certain constant or condition. Probability, everybody knows the what is probability. Probability simply is the mathematical value. But reliability is a probability of a commodity or probability of a system or probability of a device under certain conditions or under certain restriction. So this is the another additional thing to the reliability. So see that in a mobile, everybody knows what is mobile. Mobile is a hybrid system, contains lot of features, music, yeah, or your camera. You can your use for surfing. No, we are using WhatsApp, Facebook. Lot of things are there in a mobile. So see that another thing is that internal system is that the components, the small components are there. All the components are connected by your series connection or parallel connection. Okay. So this is the major thing we have heard this term series connection and parallel connection during the study of physics. No, physics in electrical circuits are there. So to study the electrical circuit, we heard the name series connection or parallel connection. So here see that the components, so it box represents one components. There in the first row, there are four components. The R11, R12, R13, R14 are the reliability of the components. So all these components are connected in a series, in a line, means in a series. And see that the first row there are four components, in second row there are another four components, third row there are another four components. So all these three rows are connected in parallel. So this system is called the series parallel connection. So see that to calculate the reliability, we need to find out what is the failure rate of a component. Failure rate is the important thing. If the component fail, then the system will fail. That means the reliability terminate there. So failure rate is the very important parameter, and time duration is the another important issue. No, time duration is another important. Why time duration is important? Suppose you have purchased your air condition. So air condition will work for few years, for say 5 years or 10 years, without any disturbance. After a certain period, it needs some service, or it some parts may be damaged, to replace some parts. So after certain period, the system will your breakdown, then needs some repair, or some goods are there, they are not repairable. So, as for example, valve, tube light, these are not repairable. Okay, so one important parameter is failure rate. That one is associated to the reliability of any component. So here Rij represents the reliability. Reliability can be calculated. Lot of formulas are there, depends on the situation. The most common formula is e to the power minus lambda t. E to the power minus lambda t is the more common formula to calculate the reliability of a system. So here Rij t equal to e to the power minus ij lambda t plus 1. So we have considered this is the general expression in arbitrary expression. That this expression gives the reliability of all these 12 components. Okay. So here time is 100 hours. It is mentioned in the problem. We have to calculate the reliability of this system for 100 hours, and the failure rate of all the components are 0.005. Here we assume that the failure rate of all components in the system are equal to 0.005. So in general case, these parameters are different. That means failure rate for different components may be different. So using this formula Rij, we can calculate the reliability of each your components, and the reliability of the entire system. How we can calculate the reliability of the entire system? So to generalize the entire system, we assume M means the number of rows and N means number of columns. So here number of rows is 3 and number of columns are 4. So M and N are assigned here. Lambda equal to 0.005, T equal to 100. This is the investigation time duration. So this is the double for loop, which is used to calculate the reliability of each component or ijth component, which is in that particular given formula. So after calculating the vector Rij or matrix, basically matrix Rij, that matrix is printed here, display R. And we are calculating the reliability of each row. So see that each row, the elements are connected or components are connected in a series. If the components are connected in series, then the reliability can be calculated by multiplying all reliability of the all components. Okay. So R equal to product. This is the product symbol of Rij. So that one is implemented here. We have multiplied all the reliability of each component in a particular row. So RR1 represents the reliability of the components in the first row. RR2 represents the reliability of the component in second row, and RR3 represents the reliability of the third row. So all these things are calculated here. And lastly, we calculate the reliability of the entire system. But see that the three rows are there, and the three rows are connected in parallel system. No. So for this reason, R equal to, for the parallel system, the reliability is calculated by this formula, 1 minus product of 1 minus Rij. If Rij is the reliability of a component and the components or devices are connected in parallel series, then the formula is this one, 1 minus product of 1 minus Rij. So here we have calculated in this for loop, we have calculated the reliability of the parallel system. Rs is initialized as 1 minus Ri. That means we have just find out the product of the term 1 minus Ri. And finally, the reliability is 1 minus this RRS. This term is denoted by Rs here, and final reliability is denoted by Rs equal to 1 minus this. Sound is coming. Sound is coming. Sound is. আওয়াজ আসছে ওখান থেকে। So see, this is the your output. So these three rows and four column represents the reliability of each component. Okay, and the reliability of first row is one, this one. Reliability of the components of second row is this one. Third row is this one, and the reliability of entire system is 0.36947. See that first row means the reliability of this component R11 to R14. Reliability of the second rows, components of the second rows R21 to R24 is this one. Okay. So in this way, we have calculated the reliability of each row, and last value represents the reliability of the entire system. Now this is the another kind of connection, parallel and then series. Previous one is the series parallel connection, and this one is called the parallel series connection. The formula is more or less same. Okay. Now there is another thing, another issue, Monte Carlo simulation. So simulation can also be done with the help of your MATLAB. That one is very useful. So basically, see that the Monte Carlo simulation is basically based on the your probability theory. Okay, Monte Carlo simulation based on probability, and there is a good connection between the probability theory and the random number. Okay. Random number, the random number means a number is coming arbitrary way. There is no specific formula to generate that number. There is no specific formula to generate the random number. If a random number is available, then based on that number, we cannot uh, construct another random number. That one comes randomly. But if we use the computer to find out the random number, then you have to maintain some formula, mathematical formula. But lot of mathematical methods or formulas are available to find the receipt of random numbers. But all these methods are designed in such a way you cannot predict what is the next random number if a particular random number is given. Even if you know the formula, which formula is used or which technique is used to calculate the random numbers, even then you cannot predict the next random number. So this is the beauty of the random numbers. So I'm not coming to that point because that one is a very complicated method, and that method is available in any book, or you can search in the Google. You can obtain the method to design any random number set. So here I have considered one very simple problem. Write a program in MATLAB to estimate the probability of obtaining 8 or more hits. Probability of 8 or more hits if a coin is tossed 10 times. Okay, using the Monte Carlo simulation technique. Okay. A real value is approximately, real value means the probabilistic value. Theoretical probabilistic value is 0.0548 for this case. Means probability of more than 8 hits out of 10 coins basically. If a coin is 10 tossed 10 times, if you toss a coin 10 times, then what is the probability? All times we get the hits, no, or we get 9 times hit or 8 times hit or 6 times or 7 times, lot of this. So the question is, what is the probability? So this is a probability theory is there, but the simulation technique gives the experimental result. No. So we know, everybody knows that the probability of getting a hit for a single toss of a coin is half. Okay, so this is the theoretical or probabilistical your concept. But if we find out the probability of hit, is it really half or not getting hit for a single turn? So that can be done by experimental way. Okay, so this is the your MATLAB code to find out that kind of probability. So C is 0, C means counting the number of hits, n equal to 10 to the power 7. That means we are repeating the experiment for 10 to the power 7 times. This is not possible by hand simulation or hand calculation. So here we are using one loop for n equal to 1 to capital N. Capital N means 1 into e to the power 7 means 10 to the power 7. So this loop is repeating for 10 to the power 7 times. So see that here x equal to rand I. Rand I, this is very interesting expression. Rand I within first bracket, see that there is another square bracket. Okay, square bracket comma 1 comma 10. So what is the meaning of this parameter? This is important. So this expression 0 1 interval, so this 0 1 interval generates the random number between 0 and 1. But another important thing is that the rand function is there, sorry. Rand function is there and RAND function is there. That rand function will generate your random number between 0 and 1. Okay. But rand generates the integer number between these two numbers. Here, see that in right hand side box, more general expression we have mentioned here. Randi 5 comma 40. This means generates a vector of 10 numbers between 5 and 40. So this interval represents the interval of the numbers. Okay, 5, 40 means all the random number are integer, they lies between 5 and 40. Okay, including 5 and 40. And 1 comma 10 represents 1 comma 10 represents the number of random number is 10. So what is the meaning of the 1? There is no meaning. So see that in the second expression. In second expression, 540 is there. That means the random number, it is a random number lies between 5 and 40, including 5 and 40. And see that 3 to 10 means it generate a matrix of size 3 by 10. Okay, two-dimensional array. It's represent two-dimensional array. So first component represents the number of rows, second component represents number of columns. So for this case, first case, 1 means number of rows is 1 and number of column is 10. That means it is a vector. Okay. So this is the meaning of this function. So here, see that randi we have used. So the number generate, the random number generate between 0 and 1. 0 and 1 means either 0 or 1 because we are considering integer. So between 0 and 1, there is only two numbers, 0 and 1. Okay. So this function generates random number between 0 and 1. And 1 comma 10 means 10 random numbers. That means x, basically x is a vector. X is a vector of size 10 and the element of each element of this vector are either 0 and 1. Okay, so this is the concept. That means using this concept we are generating a vector x of size 10 and the element or the value of each element either 0 or 1. Single command we can generate a vector of size. Means here there is no restriction to represent 8 by 1 tail by 0, but this is interchangeable. So if you assume that head means 1, tail means 0, then now we have to count down how many heads are there or how many ones are there. So for that purpose, there is another function nnz. nnz, this function counts the non-zero element from the vector x or from the matrix x. If it is matrix, then this function also work well, very well. So nnz, this function counts the number of non-zero element of x from x. So if it is greater than or equal to 8, then we increment c by 1. Okay, that means for a single trial, we are counting how many heads are there. How many heads are there means how many ones are there. If it is more than 8, then we assume that we are success, because we are trying to find out the probability of getting more than 8 hits. So for this reason, we have written C is equal to C plus. So this is one run. Okay, this is one run. But we are repeating this experiment for 10 to the power 7 times. So for out of 10 to the power 7 times, how many times we are getting the this value? This more than 8 hits. So finally the probability is C by n. N is the total number of experiment and C is the possible cases, successful cases. So this is the probability. And if you want to calculate your error, percentage of error, then probability minus this is the exact value as per theoretical probability, then you are divided by the true value. This probability means the approximate value, 0.547 is the exact value, and that one is divided by exact value. So this gives the relative error, and then it is multiplied by 100. So the total expression gives the percentage of error. And then we we print the estimated value, that is the probability we have printed here. And in second line, we have printed the error term. Okay, error term. That's okay. So these are the answer. And see that a very important thing is that the references. These are the two books which are very useful books for the optimization technique with algorithms. The first one is written by Sudhankar Naik, published from Academic Press, and second was is published from your uh, John Williams. Okay. And thank you very much. So time is over. I am going 8 minutes late. So if you have any question, then I can take one or two questions from you. Any question from audience?
Hello, sir. I have a question. Sir, suppose I have a objective function in nonlinear case where for decision variable, where decision variable takes more than two value, because suppose demand in decision variable for two commodities. So for this case, we have used summation sign in for the whole expression in objective function. So it's possible solve in MATLAB. Actually, we have used Mathematica, but there is lot of problem.
You have summation expression. That means the number. That means the expression is not definitely understandable, no, or definitely not defined properly.
Yes, yes.
Number of terms in the expression is not defined properly. But if there is a summation expression, so if summation Ci xi means there is a general expression for Ci. So you can calculate the Ci separately, and if the number of terms are n, then you repeat the for loop or use the for loop to calculate all the C's, and then you can construct the objective function. Okay.
Okay. Means breaking the summation sign, we take the all the values.
You need to you need to use the for loop to generate that particular type of objective function.
Okay. Thank you.
There is a general formula for no coefficients. So this coefficient may be used to generate the your vector, that vector. Okay. Here I have used the explicit form of the vector, but you can generate the general expression. I have not mentioned that one. It is very good question. So how we can use the general expression or general term to create any arbitrary vector? No. So this is the one part of nothing more. So if you use the for loop to generate the expression, that means if you use, say, your coefficient is Cj or Ci equal to some expression. So you use the for loop to calculate the value of expression Cj, then you automatically obtain the matrix A. We have written like A matrix equal to something. That value is explicitly given. But if you use Aij equal to some expression, that then Aij will be the explicit values of the matrix. Okay. Aij are the element, no? Ijth element is denoted by Aij. So if you generate the ijth element by using the for loop, then you can construct the matrix A.
Okay.
Or okay, if you have any more question, then you can send a mail. Then I will give the answer. Okay. Or I
Okay, sir. Thank you. Yes, yes.
actually.
Yes.
So thank you everybody. Now I'm stopping this session, and we will go for the valedictory session. So I think our faculty, Professor Shamal Mondol, is here. Professor Mondol, are you here or?
Sir, present.
Okay. So I am requesting Professor Mondol to chair this session, the valedictory session and discussion session.
Hello, sir.
Yes.
Sir, can I use link a Torah in place of link?
No, I have not used that software, but I have used your Lingo. Lingo is more better. Better than
Torah.
Huh?
Link Pro is better than Torah.
No, I have never used Torah. I have used Lingo. So you can try because the Lingo software is freely available in the website. So you can download and you can use this one. Help manual is also available, and then you can compare which one is better, Torah or Link. Okay.
Okay, sir.
Every software has some limitations and as well as advantage. So you have to identify if you compare the one software with other. Okay.
Okay, sir.
Now, if you have any question or suggestion like that, I will send the your feedback for link. Okay, I will send after completion of this session. I will send the feedback link to everybody to the your WhatsApp group as well as your email ID. Okay, then you should submit the your feedback. Very simple questionnaires are there. Two three questions are there. So after submission, your feedback, and within 1 week we will submit the we will send, basically not submit, we will send the your certificate. So if you have any question or suggestion, you can uh, mention here, or you can also mention in your feedback. There is no problem. Professor Mondol, if you have any suggestion or you would like to say something, you can say.
Uh, yeah, I think actually it is very short course, just for 3 days. I think 9 hours course. MATLAB is actually it is a vast. There is different function is there, different sides of programming. Mm. So to completely teach the students, the candidate, uh, I think it will be better for more hours, not just nine hours. Except these side by side, there is a Python course. So Python language is there also. Mm. So department, if arrange any course, online course on Python, I think all participants can compete between MATLAB, Python, C programming like this. Okay, sir.
Okay. So I send the feedback link to your mail ID, and after a few minutes, I'm sending the feedback link in the WhatsApp group. Okay. So thank you very much to all the participants, and we are planning to offer another course on your Python after 1 month or 1.5 months. Okay, if you're interested, then you can join.
Okay. Okay, sir.
Okay.